Okay, so I might need to switch to Science Tech now, and by might, I mean there's... I might need to change the title up. Might need to switch some of this around. I'll switch this over to Science and Technology, and we'll go from there. We got some Texas Tank Watcher action here. There might be a static fire for the booster here in a moment. So I'm going to switch us over to that here. First of all, good morning, everybody. How are you? How are you? Yeah, we have to hold the Steiner ship because there is a gigantic booster in the way of the ship. Yo, Jimbo! What's going on, man? Oh, dude, I got the telescope from my parents' house over the weekend. It's nothing special. It's like a little guy with a lens diameter, like maybe a baseball at best. Can we give Thomas Pisquet an internet award for going ham earlier? I would. We look like a bunch of wankers to the Port Authority, but we could have looked like a bunch of legends. Alright. So.
It's hard to have
this. Let's pull up NSF here and let's take a look. I think the telescope aperture should be measured in sports ball. Okay. Good. Whatever time of day it is, what even is time, where am I, what is life? Okay.
than being in a car, and yet
Cars?
plane crashes happen still, and people do get hurt and die on airlines. Jeez. And so it's hard to have that conversation. It's a very difficult thing, but
What's going on in here?
you have to get there at some point. And so avoiding the in-flight abort system maybe long-term makes a lot of sense. There could be an argument that you need to have something in the near term, or like you said, you really need to sort out all the contingencies that you may have during ascent, much like they did for the space shuttle. Give yourself every opportunity to abort in various ways, whether that, you have abort once around capabilities, transit landing aborts, RTLS aborts, abort to orbits, things, all of those modes are going to have to be things that get programmed for sure. And those do offer you ways to account for failures. It just doesn't save you from the catastrophic Starship stage failure. If you can develop the ability for Starship to abort from the booster, you've already arguably have more abort modes than Shuttle even did. And Shuttle was, all things considered, a pretty successful design given how it was designed, and the failure modes it did experience were not ones that an in-flight abort system would have really helped with anyway. And so
exactly, especially the re-entry one. Yeah.
Exactly.
Yeah.
So
and there's another point I want to make, but just very quickly, Thomas, I don't mean to interrupt you, but we do have engine venting from under the OLM now as well. So we are seeing all those other signs of engine chill down as well. And I want to mention that too, because it's directly applicable to what we're talking about, because one thing that really aided the shuttle in its abort modes, right? Its intact abort modes, was the insane reliability of those RS-25 engines. I mean, they were the most powerful and most reliable engines we've ever put on a rocket so far in terms of the liquid-fueled engines. And the idea here is to drive the Raptor engines to even greater reliability.
Chris is talking about in terms of human spaceflight. Remember, the context of this is abort mode, so before you say Merlins, he's talking about, like, dedicated human-rated engines, not something necessarily like Falcon 9.
Have to really focus your energy into your engines.
Yeah, absolutely. Thank you, Chris. So yeah, definitely a conversation worth having, but I think there is precedent to make Starship a reliable and safe system without an in-flight abort system.
So I've got a good question for our back channel.
Actually, fellas, I've talked about that before. You know, people ask me all the time, like, oh, what has more thrust? Saturn V, SLS, Space Shuttle, Starship? And the answer is, Starship has way more thrust than everything, probably by about a factor of 2. This thing, that super heavy booster right there, has double what a Saturn V has. We're pushing 15 million pounds of thrust here. Does Starship weigh 15 million pounds? No. No. Even with 100 tons, still no. No, not even close. So, why would you do that then? Well, the idea is that to improve the duty cycle on the Raptors. Now, Raptors do get pushed to the limits all the time. A Raptor blew up on the test stand yesterday, if I'm remembering correctly. Delta V comparison, it's not necessarily Delta V, KJ. We're talking about TWR in this particular scenario. Raptors make about 380 specific impulse. 380 second specific impulse vacuum, and probably a little bit below that in the atmosphere. Nozzle, what's called expansion ratio, does play into that, so the vacuum Raptors on Starship probably make a little bit higher than that. But the idea is that you're hurling so much thrust at the bottom of this thing when it lifts off that you could lose about half your engines and the thing will still make it into space. That's the idea. The reliability is the idea. You're not putting the engines through as much of a duty cycle. Say you launch, right, and all your engines work. All the engines work perfectly, all through ascent and landing. If I'm thinking about this right, those engines will really never go anywhere near like above 50% throttle per launch. Even with Starship at 100-ton payload capacity, they won't get anywhere close. And if you're not revving out your rocket engines every launch, they're going to last way longer. Right? It's going to last a real long time. Thanks, Vin. Look Italian. Thank you. Yes. Beppis. Yes. Do we have a boom yet? No, nothing. No. 72 meganewtons on Super Heavy versus 40 meganewtons on SLS, 33 on Saturn V, 32 on the shuttle. Ha! He said duty.
Stay tuned best we can.
Just like what Rocket Lab is planning to do with their engines. That's right, Penta.
Since going forward, I don't want to talk over the test with I want to be offering an in-depth answer, but I don't want to shorten an answer just so we don't talk over the test. So we'll come back to questions in a bit. But right now we are standing by for a static fire. Definitely multiple engines being chilled under the booster. Hard to tell the exact number, but that hypothesis of maybe a 3-engine test maybe having some merit.
I think you're right, based on what we're seeing. That 3-engine firing here could very well be in the cards based on the amount of venting we're seeing under the OLM right now.
And we'll of course keep a closer eye on that once we get to ignition. But this is Booster 7 testing. It is the beginning of the window 2, potential for Ship 24 to get some testing later today, but SpaceX has opted to start with the booster, Bird, and the Booster 7 static fire could be imminent here.
Let's go, Caps!
I'm going to bring this really quick. Damien, thank you for becoming a Red Team member, as well as Brianna. Thank you for a Red Team membership. Appreciate that support.
Indeed. And this is what we call Texas tank watching at its finest, as we literally look at a big tank next to smaller tanks, seeing when the engine will fire here. So if you are just joining us, we are standing by for an anticipated static fire of Booster 7 here. Based on the amount of venting we are seeing under the OLM, could very well be a multiple engine static fire here. So again, like, definitely keep your questions coming, because our test day, even after they static fire here, isn't over.
Nothing yet,
because they've still got, we do have indications that they plan to do stuff with Ship 24 as well, and always the possibility of multiple static fires with the boosters, right? We have seen that. We've seen multiple static fires from the same vehicle before on the same day.
I'll also add, there's possible for just multiple engine tests period. There could start with a spin prime or something like that before the ignition for a static fire, and have a recycle in there. So there's definitely potential for a couple different test sequences.
Yeah.
Again, folks, standing by, we're trying to not talk too much because it is hard to know exactly when these tests will occur. We don't want to talk over it. It's also possible the test is many minutes away,
Could be a 3.
but we are in the part of the countdown where a static fire could occur very shortly. Again, multiple engines chilling on the bottom of booster 7. So that gives us an indicator that we are close to some sort of engine test. Hope definitely potential for a static fire based on the overpressure notice, but unclear whether that'll be the first test they do. Although we certainly hope so. That would be very exciting. And also another clear indicator, if we do catch wind of that siren, that would be a sign that it is in fact a static fire. Haven't heard that yet, but also sometimes the mic doesn't quite pick it up, so.
And the other thing too to bear in mind here is that, you know, some of the visuals, because we got asked this question earlier about, oh, do we have a timeline we can show? Some of the visual markers do keep changing here as they're getting more and more familiar and more comfortable with the vehicle, and as they keep learning things about its operation on the pad. So just because we've said before, like, oh, we've seen X, Y, and Z, doesn't necessarily mean all those things carry forward. This is something Adrian is really tracking on our back end here. So that's why we're sort of remaining a little bit more quieter and subdued on some of the things we're saying here, just because we don't want to be distracted answering a really big question when the big fun thing happens.
Yeah, exactly. You can see that frost ring. I don't see a frost ring, at least evidently, on the top tank. The liquid oxygen is on top, right? I always have to check myself when I say this.
I believe oxygen's on the bottom, right?
Methane on top for Starship.
Yeah,
methane's on top. Oxygen. See, I always get that back. That's why I check.
Bottom, yeah. The only way I remember it is it's the inverse
Thomas,
of SLS.
Can you hear me?
Oh, okay. So yeah, you can see the frost ring very evidently on the bottom of the oxygen tank at the bottom of the rocket. Don't see a super obvious one on the methane tank, but that doesn't mean methane isn't on board. Sometimes it's just not.
Anybody have an idea of why? Cross-chatting? Yep. I'm having a couple of different conversations all at once. I got a conversation going on my phone. I got a Discord conversation. I'm paying attention to what NSF is saying and watching the footage and watching you guys all at the same time. Hi, Smoke. How are you? Yeah, that's the hustle, dudes. Got to do it. The denser one goes on top. Methane's more dense than LOX? Yeah, that'd be cool.
Yeah, BN1 was oxygen on top, fuel on the bottom, and then they switched after that. Yeah, and the ships are also the same as the boosters now.
BN1, there's a throwback.
Throwback.
Smoke to Blue. No, I'm okay. You're doing all right? Hey, I'm getting confused with the Artemis thing. So they actually launching Friday? Because now I'm seeing a launch for Monday or Saturday. They did move it to Saturday, Smoked. Saturday at 2. Temperature differential. It really has to do more with center of mass, fellas. Think about it for a second. Think about where the payload is on a shuttle versus the payload on Starship. Super heavy. Payload's on the side on the shuttle. So it makes sense to put your densest propellant, your propellant that you could store at the highest density, at the front. Why? Why would you do that? Center of mass goes first. Want to keep the with the shuttle, you have the shuttle's hanging off the back of the external tank. So the shuttle engineers had this crazy idea of putting the LOX up front for stability, because LOX can be stored at a much higher density, much higher pressure than liquid hydrogen. Center of mass out in front, think an arrowhead. Think shooting a bow and arrow. You have your weight up at the front, right? Then you have the stick, and then you have a feather at the back for stabilization. You want the rocket to fly like an arrow. How do you get it to fly like an arrow when you have a 60-ton orbiter hanging off the side? So they put the LOX up on the top. They carried that over onto SLS, not necessarily for stability, but that's because that's how the shuttle was engineered. So they would know, for instance, how to do propellant filling, right? So with Starship, they flipped it. Why? Why would they flip it? They flipped it because they don't want Starship doing a nosedive when it comes into land. Think about it. They put the LOX in the back for balance purposes. It's also the reason kind of why they have header tanks up at the top. Yeah, Kopi, somebody just linked that. That's really cool. Hey, Logo. I just arrived to the stream. Did NASA unveil what happened with Engine 3, the SLS? Why wasn't it venting correctly? Sure. I've been asked that question a lot lately. So, Loco, I listened to the press conference yesterday, and the short answer is they're not sure. Now, okay, I want to be very clear. And no, I'm not just doing damage control for NASA, okay? They don't know. They don't know because they haven't gone through all the data yet. They haven't combed through the telemetry to prove whether it was Engine 3 conclusively or not. Now, okay, Loco, this will get a little bit nerdy, but you have to understand what I'll try to illustrate is like the context for how NASA goes about thinking about things and why they would say, well, we're not sure. Because that would seem like a stupid thing to say, right? It would be, you're not sure? It's your rocket. What are you talking about? But we spent a good amount of time analyzing and listening to a press conference yesterday. So, comb the telemetry. Found anything yet? Not a thing, sir. All right, so Loco, hear me out. They don't know whether it was Engine 3 or some other type of system, okay? The reason why they don't know for sure is because in the bleed system, the hydrogen bleeding system on SLS, on each engine, there's two sensors. There's a developmental sensor, or what's called a developmental flight instrumentation sensor, or DFI. And then there's a OFI, temperature sensor, operational flight instrumentation. Now, what's the difference? The DFI sensors are there because this is essentially a beta test of the rocket. This is making sure it works. You want that extra sensor and redundant sensor capability with the test flight to make sure everything gets logged and to be absolutely sure that the rocket is doing exactly what you think it's doing. Okay? Exactly what you tell it to do. So here's the thing. Engine 3's operational flight instrumentation, that basically the thermometer in that bleed line was reading correctly. Okay? That was reading right. The DFI sensor was not reading correctly. It was off by about 30 degrees. So they have two sensors that are on the same line in relatively the same spot, and one is reading different than the other. Okay? You understand it's a complex system, and without taking it apart, it's very hard to say anything for sure. Exactly. So, all right. So you'd think, okay, that sounds like a bad sensor. Well, you don't know that for sure. You won't know until you go and take the damn thing apart, like you said. Good call. Do you want to do that? No, you don't want to waste time. So what NASA's doing is going through the sensor, going through the telemetry, and figuring out if they can prove for sure with the data, if they could prove it for sure that it's a bad sensor or not. Here's the thing. Now, this is where this gets super freaking complicated. One bad sensor, but which one? You need to prove it. Exactly, Midget. But here's the thing. It might not even be a bad sensor, guys. It could be something else. We're not talking about just a simple construct of two sensors reading a temperature indication here. All right. So, Loco, this is where this gets a little bit more complicated. So, during the green run, which was, I have a picture of the green run, or a GIF of the green run on my main screen. It's that over there. See the 4 engines doing the piggly wigglies? On the green run, they got the engines to bleed correctly. They got them to bleed just fine. But when they did the bleed system, when they did the bleeding mechanism, or the bleeding procedure on the engines on the green run, it was different. It was different than what it was on the pad when we watched it go the other day. It was different. They did a different fueling procedure. The big difference here in this fueling procedure, okay, is that they bled the engines. They bled the engines while they were filling the fuel tank, while they were filling the hydrogen tank, and it worked. On Monday, they filled the hydrogen tank up fully and then tried to bleed the engines. Now, why? Why would you change it? Well, like that was my question. Why? Oh, we got a vent from the booster. Could be WW. Well, we wouldn't rule it out. Now, why would you change the fueling procedure? NASA changed the fueling procedure based off of data that was crunched from SLS's green run. They were running into this problem. They were running into a bleed system problem and leaks with hydrogen on the SLS core on the green run, but it wasn't the engine bleed that was causing the problem. It was the hydrogen vent lines in the catch can. The catch can thing, the thing that leaked during the wet dress rehearsals, during the WDRs. That thing was leaking like crazy. So they implemented a fix after the green run on pad 39B to compensate and make sure that it doesn't leak as much. And that fix seems to have worked. You just have to figure out the right way to get it done. But in changing that hydrogen catch can system, which is also designed to bleed out hydrogen from the system, that's why you have a catch can and a scavenging mechanism at the place where they connect. Because I don't know if you guys ever know, like, if you're filling your car up with gasoline, right? You ever fill your car up with gasoline and you're sitting there and you're holding the pump and you see the blurry come out of the gas tank? Fumes like to come out at points of interface. And fueling your car up is a good example of this. You can see the vaporized or the atomized fuel, or the gasoline vapors coming out of your fuel tank because you're pushing gasoline in and it's blowing gasoline vapors out. Similar idea. They have a catch can system in there to catch those vapors so they don't ignite something. So they changed the fueling mechanism from the green run to the wet dress rehearsal. And that's why you don't know for sure if this is a bad sensor. The different fueling procedure could have broken a sensor. It could have caused the sensor to malfunction. Or it could have caused the sensors to act in a way that they've never seen before. Why? Because you're trying something new. It's possible, Hellfish. Don't change the settings during qualifying. That's right, Geek. That's what I would do. Now, personally, that's me. That's what I would do. Now, there is another component here. It gets a little bit more complicated now, right? There's another component here. They didn't just change the fueling procedures because of the catch can and stuff on the hydrogen fueling mechanism, okay? The other reason why they changed the fueling procedure and they changed the time when the engines bleed, right, to when the tank is fully fueled instead of when the tank is being fueled, is because hydrogen is a precious commodity at 39B, believe it or not. SLS is still using the hydrogen tanks from the Apollo program and the shuttle program, subsequently, at 39B. They are working on upgrading the hydrogen system for more storage capacity. There's a big new hydrogen sphere that they're working on, a hydrogen ground service fuel tank, right? That they are working on. It's not finished yet. So what they did is they also changed up the fueling mechanism. They changed up the fueling procedure and part of the catch can mechanism to try and make it so they wouldn't have to worry about replenishing the pad, because the pad only has enough fuel for like maybe 1 or 2 recycles before you literally run out of fuel at the launch complex. Because hydrogen, think about it, every time they pump that hydrogen in and some of that liquid hydrogen turns to gas, you're losing fuel quantity. It boils off. And in the chill down, every time they go to fuel the vehicle, some of it will boil off because you have to cool the vehicle down, remember? That's why the engine bleed is the thing in the first place. So, because they were worried about not having enough fuel for a recycle, they changed the fueling procedures and ended up having to recycle it anyway. Now, fellas, I know that sounds stupid when you say it like that. But the most important thing to understand is that, look, now is the time to implement changes if you think it's going to make it a better launch vehicle. This just goes into the waterfall style testing that NASA does. This is a beta test, all right? You ideally, like, think of a video game being put out. You can get away with changing stuff in the beta test. That's fine. You don't want to go screwing around with that stuff after, when you release the game, right? Ideally. Call of Duty, I'm looking at you. See what I'm talking about? So, Loco, long story short, it could be a bad sensor. It could be the fueling mechanism. It could be the ground service fueling equipment. It could be the way they go about fueling it. Remember, they did run a fueling test to make sure that the catch can worked because they needed to implement those catch can fixes from the green run, right? So, that could have caused the problem. The different fueling mechanism could have broken a sensor. Or they could have fueled it in a way this time around that the sensors didn't like. But it is important to note that a DFI sensor is malfunctioning. A developmental flight instrumentation sensor, meaning a sensor that's only there because it's a beta test. That sensor won't be there on the operational vehicle. On Artemis 2, 3, 4, 5, 6, blah, 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 blah. NASA, whenever they launch a new vehicle, they always run insane amounts of sensors on it. To the point where they're adding like an extra, probably a couple thousand pounds of sensors and wiring. The reason why is they want to be absolutely sure that the data that they're getting from the vehicle is good. And this is why this is why they were like, the DFI and the OFI sensors on engine 3 for the bleed system are not showing the same thing. Here's the thing. Here's where this gets really freaking complicated. The DFI and the OFI sensors were reading differential temperatures. One was reading minus 420 Fahrenheit, and the other one was reading minus 380 Fahrenheit. The sensor, the flow rate sensor at the end of the bleed line was reading correctly. So engine 3 was being bled. They did get hydrogen to flow through the engine. But the sensors said that they didn't. See how complicated this gets? It could be a bad sensor. It could be the way you fueled the vehicle. If you fueled the vehicle in a different way that you did last time with this core stage, so you know, because you fueled it in a different way, that you maybe this way broke the sensors. Maybe fueling it this way is flowing hydrogen over the sensor in a way that it didn't before. Signs are pointing to a bad sensor, but this is often a lot more complicated than that. Could be a bad sensor. It could be something upstream. Anybody that works in IT troubleshooting knows exactly what I'm talking about. Restarting your computer doesn't fix the problem. It temporarily fixes the problem, but it doesn't fix the underlying issue. NASA has to find the underlying issue. If you have a bad sensor, what caused that sensor to go bad? Did the fueling procedure cause the sensor to break? Is it just because it's a DFI sensor? Is the sensor calibrated correctly? This gets complicated very, very quickly. What would be your tentative launch timeline for Starship, Juicer? Probably in the middle of October, if I had to guess, judging by what I'm seeing here. Maybe the end of September, maybe. So, yeah, Loco, long story short, they're going to try again on Saturday at 2 p.m. And they're going to try and implement some fixes to verify that the sensor is what's going wrong. And my question, well, not my question, my gut feeling is that if they prove that that DFI sensor is not working correctly, they prove conclusively, they'll send it. They'll let it fly. The reason why is because if they can If you can prove that that DFI sensor is malfunctioning and the engine is bleeding correctly with data and numbers, and obviously like just a camera pointed at the engine showing frost coming off the damn thing, they'll send it. The DFI sensor is not needed. It's not needed. It would be nice, but it's not needed. Remember, this flight is about getting good baseline data. They need to see with numbers, and obviously the thing flying up into space, how it works. How good does SLS work? And when I say how good does SLS work, there's a caveat to that, because this thing is always as freaking complicated as the second you think you got it figured, it's always way more complicated. It's like in Men in Black when Will Smith thinks he has it figured out and then Tommy Lee Jones just shows him something that blows his mind. You know what I mean? Like it's that. It's always more complicated than you think it is. So, in that regard, how is it more complicated? I say they have to make sure on Artemis 1, they have to show that the vehicle is operating correctly. How do they know how do they know if it's operating correctly? Well, that's called data analysis. All right? Or it's just called regular analysis. So, they had some bookworms, some nerds doing the math out like on a computer to basically come up with an idea of what they think the vehicle is going to do first time they launch it. And then what they have to do is once the vehicle does launch, they have to make sure the telemetry numbers are matching their analysis. The closer you can get those two, your prediction and your result, the closer you can get those to each other, the better the engineering is, the better you're going to understand the vehicle, and that can lead to great reliability down the road. But you have to get it right. Your analysis has to be comprehensive, and the vehicle has to basically, if the vehicle does exactly what you think it's going to do, exactly what you quantified in the data analysis, or just the straight analysis on this thing, and your testing data, if the analysis, the testing data, and then the flight testing data are all concurrent, you're good. They'll certify it, and they'll start working on Artemis 2. But even after Artemis 1 flies, figuring out all three of those things and making sure they're correlative and making sure they're close enough to prove with numbers that you understand what the vehicle's doing and you understand how SLS operates, that takes time, dude. It takes time. It takes a lot of time. Hey, human. Long time no see. If it doesn't fail, explode, or shut down on the pad, it's working correctly, maybe. Suffer Sauce, what I like to tell people is that a rocket you can usually tell if a rocket's performing well if it's making an explosion, but the explosion is going in one direction. If the explosion or fire is going in multiple directions, nope, you did something wrong. If the explosion is going all up in here, then you did something wasn't right. You didn't understand what you made. And I can't stress this enough. If anybody wants to get into engineering, if you're a younger kid, you want to get into engineering, it's not why did you do this way? What are you trying to do? What are you trying to do? And within that question, you have to engineer an application to answer that goal, okay? You have a stakeholder expectation. What are you trying to do? Okay, I'm going to build a vehicle to do task A here, okay? What do I want task A to do? Say I want this vehicle to go and land on the moon and come back, okay? And I think it's going to perform like this, all right? When you test it, if the vehicle isn't doing something that you didn't, if the vehicle's doing something that you didn't anticipate, that means you didn't do your analysis good enough. This idea can be applied to Starship. These engineering fundamentals can be applied to Starship. They can be applied to the space shuttle. They can be applied to SLS. They can be applied to your model rocket. Anything, any type of engineering. What are you trying to do? And do you understand your vehicle? Do you understand the thing that you made? Do you understand how it works? Do you know that it's working as intended? Those are big things. Then that second one is that second one is the difficult part. Really difficult. How did the move go? Everything's going good, human, yeah. Yeah, there you go, Neuro. Seriously, though, you just could simplify the explanation a bit more. Telemetry is telemetry. A rocket simply has more than a car. Yeah, something like that. Does that make sense, Loco? So I guess mass would be a factor in it, but why not have 3 sensors rather than 2? At least then, if there was an issue, as SLS, they would have 2 to 3 versus 1 to 3. Yeah, Wolfie, but you're not thinking... That's right in the construct of just 3 sensors on a bleed line, right? And obviously you have to take mass into account, but... Why? Why do you need 3 sensors? Wolfie, let me put it to you like this. In hindsight, especially after the information that NASA has presented to us, in hindsight, it's really easy to say that you could have 3, you need 3 sensors now. That's a really easy thing to say given the information presented. Where was that analysis before this problem happened? See what I mean? So you're asking like, oh, why don't they just put in 3 sensors? Well, you don't know until you know. That might be a viable fix. But once again, NASA has to prove that it's a bad sensor. Just because the sensor is giving you an off-nominal reading doesn't mean the sensor is bad. They have to figure it out. They have to prove it conclusively, which is why NASA is saying, well, we don't really know right now. We got to figure it out. How big are the sensors? Oh, I don't know. A DFI temperature sensor? This big? It's not very big. So it's... Search for bleed in this article. Yeah, what we're talking about here, Wolfie, is... That's a, you know, at Ascendant, that's a good way to put it. What we're talking about here is an unknown unknown. You won't know you're going to need 3 sensors potentially until you prove that you need 3 sensors. And look, you could do all the analysis in the world. You could do all the analysis in the world. You're not going to know if that analysis is good until you fly. You have to have some kind of or type of correlation, right? You have to have some correlation there. Because data is about plotting points, right? And then based off of how the points are plotted, then you form a conclusion. That's just being scientific. The solution here might be that the fueling procedure broke the sensor. Then, well, whatever. You don't need the DFI sensor. As long as you verify that the OFI is giving you a good reading, then you're good to go. It's not just... Yeah, that's fine, buddy. It was just the thought that crossed my mind. Yeah, no. Don't get me wrong. Like, Wolfie, I'm not saying, like, no, you're wrong. My whole point with my responses is to try to get people to think about it. Because, dude, like, I could sit here and I could give you an answer like, why, you know, oh, yeah, maybe 3 sensors might fix the problem. But I try to get you guys to think about this, to think about the construct of and why you wouldn't want more than 1 sensor, or maybe 3 sensors. What risk analysis did you do to show that you need 3 sensors, other than just hindsight, right? Like, I'm not saying, no, that's wrong. Dude, the solution might be 3 sensors. I have no freaking idea. The whole thing that I'm trying to point to is that it's not what you know, it's what you can prove. It's a good training day quote. You have to prove that the sensor's bad. If you can prove the need for 3 sensors, then that's what you got to do. And that will get you a better reading. I call that, like, that mentality, like, I call it defensive engineering, right? It's not just about seeing the effect, right? And being like, oh, 1 sensor is bad, the other sensor is good potentially, right? So let's just put another sensor in there. That could potentially add waste and make the vehicle more expensive. I'll give you another example of this. I'll give you a good example from the shuttle program. The shuttle program, the RS-25s were super freaking reliable. They were super reliable. They really never had a problem except maybe 1 mission, like STS-51 like B or something, where Challenger had an abort to orbit. And that was in 1985. That mission had a bad sensor on it. One of the sensors got a slight off nominal reading for like a millisecond and shut the engine down just out of an abundance of caution, right? You know, that was in 1985. Then they worry. Then SRB blow-by happens, and then Challenger happens, and then after that, somebody along the line basically decided that the only way to make sure that the RS-25s worked every time is to literally take them apart and rebuild them every single time. That's the only way to be absolutely 100% sure, 100% sure that those engines are going to work if you rebuild them every time. I would say rebuilding the RS-25s every time, and now keep in mind this is an EJ opinion, this isn't NASA's opinion. NASA clearly disagrees with me on this one, and that's totally fine. I'm just some guy that streams on Twitch, so take my opinions at face value, okay? Personally, I don't think that's any way. That's not going to give you a more reliable engine. That gives you a safer engine. And now costs go up for the same launch vehicle. The only way to really make that work in this particular scenario that I'm talking about, it would be to do more engine testing. Do more engine testing. Put a shuttle engine on the test stand and fire it a bunch of times. See what breaks. See what doesn't break. And then apply that data and that testing analysis to your flight analysis. That will give you more reliable engines over time, inherently making the vehicle more safe. Or you could just choose to rebuild the engine every freaking time in the name of safety, and then, yeah, of course they'll work every time, but, you know, doing that is inherently failing at what the stakeholder expectation of what the shuttle was trying to accomplish. The shuttle was trying to make spaceflight more affordable by essentially reusing your upper stage, right? And your first stage as well, because the first stage is technically the boosters. You fish the boosters out, you bring them back, you disassemble the casings, you turn them, and you repack them, and then you send them back to the launch pad. And then the only thing that gets expended is that big giant orange tank, which is fine. You can keep building those. They're very simple. It's just a big tank. Those can be manufactured in mass, no problem. But you get your upper stage back. You get your second stage motors back. The shuttle was supposed to lower the cost and pioneer reusability. It was supposed to lower the cost of access to spaceflight. See what I mean? That potentially, in that particular scenario, I'm not going to say it was a needless redundancy, but it was a change that was made. It was a change that was made that was essentially at odds with what the shuttle was designed to do, and that ended up making the shuttle way more expensive because the costs are going to go up for your space shuttle if it spends 3 months after every launch on the ground having its engines rebuilt. So sometimes just shooting from the hip and like adding another sensor just to make sure that this problem never happens again is not necessarily the right solution. Oh, we had an engine malfunction. Oh, the only solution, the shuttle engines aren't safe. The only solution is to rebuild them every time to make sure that they absolutely work. On a vehicle where you're trying to pioneer reusability and trying to basically operate it like an aircraft. See what I mean? This is why NASA is being so careful with SLS. This is why there's like, oh, we gotta review the data. This is why this matters. This is really important. This could cost lives down the road if you're not careful. Got to be careful. You got to make sure the analysis is done right, and you have to make sure that that you can prove that sensor is bad. Oh, we got some ice coming off. Oh, stage vent down. Damn. Depress vent. I think so, Nero. Does that make sense, fellas? I know I talked your ear off there for a second. Some people just want to sit here and watch Super Heavy. That's fine. My question was the sensor that gave them the readings that led to the scrub part of the operational package? It's a test sensor, Hellfish. The turbopumps for the fuel and oxidizer were inspected and rebuilt as part of that process. That's right, Box. Is what we're seeing a bad thing? They brought the booster down from flight pressure, meaning that, and they're venting, meaning that the test was aborted. Yeah, we're a little ways behind, but not by much. You see what I'm talking about, dudes? This stuff, it's not as, like, I don't want to try to sound like, you know, I'm making excuses here. But there's a very good reason why you don't just say, oh, it's a bad sensor. All right, put another sensor in, it'll be fine. You don't do that. Don't do that with spaceflight. Don't do that with rockets. Don't do that with any type of engineering. That's a Band-Aid fix. It's a Band-Aid fix, and if you make Band-Aid fixes your operational strategy, right? If you make Band-Aid fixes the norm, that's going to get somebody killed. And I could cite a bunch of specific examples in the space program that have gotten people killed, Soviet space program and American space program, of why you don't do stuff like that. Just letting you know that the Battleship Texas Foundation has a live feed up and she's towing to dry dock right now. 90210, yeah, I saw it, dude. Yeah, very cool. Misses the root cause. Exactly. They sensor test systems for a reason. Hey, take that off. Test it. Is it faulty? Put on a new one. Saver, yeah, I mean, that would work. But you never figured out why that sensor broke. Oh, we got another vent down. They depressed the fuel lines there. Like I said, man, everybody goes about saying, oh, spaceflight is difficult. Space is hard. We had a bad sensor, so spaceflight is difficult. I hate when people say that. I try to explain to you as best as I can in layman's terms why a bad sensor is such a big freaking deal. You don't know how that sensor broke. What broke it? How did it break? Why did it malfunction? The other sensors are working fine. See what I mean? It's not just, oh, the sensor's bad, replace it. You're going to replace it, it'll break again. Guaranteed. It feeds into the, I try to explain the mentality, like what NASA's thinking about and why they do things the way that they do. And why sometimes saying, I don't know what's wrong with it is the best answer. This is a test flight. You're going to learn something new. No one's ever launched an SLS before. There's no prior information, maybe save for the space shuttle, to know. Same case with SpaceX here. Why do you think they just aborted? Because they saw something that they didn't like. Because no one's ever tried to do something like this before. All it's going to take is 1 or 2 Band-Aid fixes and the thing blows up. That's it. And then, oh great, now you don't have any first stage and now you blew up your launch pad. Yeah, there you go, Train Man. Mm-hmm. Pretty sure that this pad vent is the equivalent of the old Starship tri-vent. Then why did they vent the methane tank, or why did they vent the LOX tank? Yeah, you can't just let the Band-Aid fixes fly and call it a day. Letting the Band-Aid fixes fly, figuratively and literally, is why Challenger exploded. Like, the SRBs were malfunctioning. They knew they were malfunctioning. The rocket was getting put into a failure mode every time they launched it in cold conditions. But because it didn't malfunction in any of the prior cold conditions, no one ever bothered trying to fix it. They said, oh, you get SRB blowby and the O-rings don't work, but then the SRB seals because the 2 segments weld themselves together. That's fine. That's a good redundancy. That'll work. Now it's triple redundant. We have 2 O-rings, and then if those don't work, then the SRBs weld themselves together. That's triple redundancy. That's 3 sensors. See what I'm talking about, Wolfie? Nobody ever bothered to test what the rocket would do in high wind conditions with that triple redundancy working. That's what got Challenger. It wasn't the O-rings. Not a lot of people know this, and every single documentary I see about Challenger glazes over this fact. They say, oh, it's the O-rings. Oh, it's the O-rings. So that sends out a message like, oh, NASA knew the O-rings were bad and they just sent it anyway. No, it's more complicated than that. It's way more complicated than that. The O-rings sealed and they worked. If the O-rings failed, then the booster sealed itself because the gases would basically weld the segments together when you got SRB blowby. And it worked in the past. It worked just fine. What every documentary misses is that STS-51L had 2 launch constraint violations that day. 2 of them. It was too cold and it was too windy. And they said go anyway. So it launched. The SRB if the SRBs failed and you got straight blow by on the pad, Challenger blows up on the pad, but that didn't happen. The SRB sealed, just as they had seen in previous flights. But here's the second part: too windy. They hadn't tested that SRB segment weld together redundancy thing in high wind conditions. They got into the upper atmosphere. They hit like 400 or 500 mile an hour wind gust up in the upper atmosphere, and that wind gust cracked that welded segment. That was the end of that. Is the wind. It was the wind coupled with the bad O-ring failure, coupled with that SRB blow-by, that caused the problem. That's what caused Challenger to explode. And if you think I'm talking out of my tail, you could go read the Rogers Commission. Neil Armstrong was on the Rogers Commission, the Challenger Accident Investigation team. It's called the Rogers Commission. You can go read it. He said the same thing. I'm inclined to believe Neil Armstrong. Yes, that Neil Armstrong. I'm pretty sure he knows something about spaceflight. I think that is a false equivalency. The old try vents would keep going after the abort vents. All right, well, we'll see what we can see here, Blue. See what I mean? Implementing Band-Aid fixes like that, Wolfie. And once again, I'm not trying to pick on you. I'm not trying to say you're wrong. I'm trying to say you gotta, it's not just simple as like, oh, why don't they just put another fix in? Why don't they just add another sensor? That can get people killed. Seriously, that's a little bit of hyperbole on my part. I don't mean to imply that an extra sensor on the bleed line is going to cause the vehicle to malfunction. What I'm trying to tell you is that I don't know if it's going to cause the vehicle to malfunction. It might. You're introducing new variables here. See what I mean? That's why NASA is so adamant about saying they don't know. Because they don't know for sure. Because sometimes saying you don't know, especially in testing, is the right thing to say. It's not a lie. It's not being vague. You don't know. Got to figure it out. We're NASA. That's what we do. We figure things out. Well, not me, but that's what they said. Richard Feynman was on it too. That's right, Lazarus. Yep. Yep, Sarver. Exactly. So this is why they saw the bad sensor and it spooked them. They said, nope, nah, hell no. No. Let's not even try. Don't even bother. Not worth it. So long story short, with SLS, they will try to implement this fix and try to verify that the sensor is bad, or if it's not, and they will come up with a solution on that. The thing is that the next time you do that is the next time you're going to have to go and prove that for sure is on Saturday during the launch countdown. That's the only time they can verify it, because they can't fill up the rocket with hydrogen right now. You don't want to do that, because then that in itself could be introducing more failure modes, because the rocket wasn't designed to just be tanked for funsies. You know, when they fill the rocket up with fuel, it's designed to launch. Tanking and detanking and tanking and detanking and tanking and detanking, I'll just fill it up with fuel again, can introduce stress into the vehicle, because it's expanding and contracting and expanding and contracting and expanding and contracting over and over and over and over and over again. This puts the tank through a load cycle. And that, you don't want to do that unless you absolutely have to, or you intend to launch, okay? The reason why you don't want to do that so many times is because doing that can cause the foam to crack. You can cause stress cracks in the aluminum. Any airplane mechanic will tell you, aluminum cracks. It cracks like concrete. There's stress fractures inside of aluminum pieces. Happens on airplanes all the time. If you ever flown on an airplane and you looked at the flaps on the airplane and you saw that it has like holes cut into the side, like looks like Swiss cheese almost, it's because they're cutting the stress fractures out of the wing so the crack doesn't get any worse. This does happen. And you don't want to put the rocket into another failure mode where you tanked it too many times and you could cause a crack. That's no good. That's material fatigue. Learning about material fatigue with NASA or any type of mechanical engineering is called FEA, finite element analysis. You won't know. You won't know the FEA on that aluminum on SLS. You know, it's rated for a certain amount, but you really don't want to test that, because if you tested it, that means it exploded. So you don't want it's not just as simple as like, oh, let's go fill it up with fuel. Let's figure out that fix right now. No. You want to do that as little times as possible, because you don't want to introduce another failure mode. You don't want to introduce another variable into your testing regime. That could screw with your data. Oh yeah, I call it aluminum. That's right. Yeah, Hibbit. That I get what he's trying to get at, Hibbit, but the fundamental flaw in calling these launch attempts a wet dress rehearsal is intention. You don't know they're intending to launch, and they're running into problems. This happens with every testing regime. No one bats an eye if they abort a static fire. SpaceX has aborted this static fire 3 times this week. No one cares. But when NASA does it, it's like, oh, did you really mean to launch the vehicle? Yes, they meant to launch the vehicle. You dingus. It's possible, Neuro, yeah. I can't say for sure. No one can say for sure. Only NASA can when they get the data figured out. Expansion and contracting during charging and discharging is also causing a degradation of newly developed silicon graphene battery technology. So, yeah, you got it. And Logo, once again, it's not saying that this could or couldn't blow up the vehicle. The thing is, you got to know for sure. You got to know. They ever figure out the ground communication issue? That was solved, Thorin. I forget what they did. I would guess if NASA had the sensor as a known issue, it was not a known issue. The bleed valves worked correctly on the green run, Shy. But they changed the way they fueled. They changed the fueling procedure, so you can't rule that out as a possible thing. What are you saying? But seeing the sensor go bad and not knowing why is why they scrubbed in theory, right? No, not in theory. That's why they scrubbed. You do. If that sensor is bad, right, and you roll the dice and you send it, and the sensor was bad, then the thing flies into space just fine. You know, you're rolling the dice though. If that sensor is not wrong and the sensor is working correctly, and say your fueling procedure wasn't right, and there's gaseous hydrogen inside of engine number 3, when they go to start it, it blows up. It'll hard start and it'll explode. So it really comes down to, when you get to these unknown unknowns, Shy, it really comes down to how willing you are to roll the dice. It's a gamble. You don't know if it's going to work. But you want to improve your odds as much as possible, right? Yeah, interesting, Ascendant. Yeah. I wish we knew specifically what type of sensor it is, i.e. thermocouple or some sort of IR sensor. It's a temperature sensor. It's a temperature sensor that's reading in Rankine, believe it or not. It's probably because it's derived from the shuttle program. What's Rankine? Rankine is a, if I'm remembering correctly, it's a temperature measurement that is based off of a Fahrenheit scale, but starting at absolute zero. It's Fahrenheit, but zero is absolute zero, is 0 Kelvin. If I'm remembering right, I could be wrong. Could be wrong. Yeah, that's what I mean. The unknown unknowns is what we can't have. You want to minimize that as much as possible, Shy. Yeah. Okay, cool, Hokey. Yep. Can you tell me something that both Falcon 9 and SR-71 used? What? Is that a trivia question, Apatoxin, or are you actually asking? Triethyl aluminum and triethyl borane. Yeah, the pyrophoric starters. Yep. They needed to do that with the SR-71 because when you get up past Mach 3, you shut the engines off. And the SR-71 didn't have starter motors for the jet engines. It's too heavy. So they used a pyrophoric igniter to be able to relight the engines after the SR-71 came down from supersonic flight. Yep. Oh, I hope you're wrong. That would be a horrendous measurement. Blame the Scots. I just learned that today. So cool. Yeah, Apatoxin. Yeah, really neat. Oh, yeah. Yeah, Apatoxin, this is what I mean when I say, like, Falcon 9 doesn't do anything new. Seriously. Pintle-injected gas generator engines? Not anything new. Actually, the pintle-injected gas generator is new. Gas generator engine itself, not new. Pintle injection, pintle fuel delivery systems, not new. Grid fins, oh, those have been used on bombs forever, for 40 years almost. T-tab to restart a gas generator, oh, that's been used all over the place. Sure. Also, I'm pretty sure they've wrapped for the day. Frost is starting to recede and no further pad vents.
Booster 7 is also not done testing though, so maybe if it hasn't beaten the record yet, it might down the line. I think we're going to have to get back to you on that one. I'm not sure how easily we can pull that out, but we will try our best.
Well, Adrian might have some of that data from his tracking, but yeah, it's a very good question. Let us confirm with Adrian, and we'll get back to you. Yeah.
They do, Hokie, right?
Yeah, there we go. Let's see. A question here from Kyle asking, has a booster outer ring engine ever been tested? Yes, twice. Both of the Booster 7 static fires were actually outer ring engines.
That's right.
So, yeah,
vent down.
Absolutely.
Indeed.
I read that the turbo, like cars and rockets used, was designed for World War II, a World War II dogfighting plane, and then further developed for rocketry and space flight, right? Nice. Turbine technology was or the idea, of a turbine as we know it, Saber Sauce, was invented by a guy named Frank Whittle, who's a British aerospace engineer. Frank Whittle made the first turbojet engine. So the idea of compressing gas, lighting it on fire, and then shooting it through basically a glorified pinwheel to spin your compressor, and kind of just keep going with that as long as you can deliver fuel. A turbojet. That Frank Whittle came up with that. Now, simultaneously though, the Germans during World War II, the engineers at BMW, yes, that BMW, were also trying to figure out turbojets as well. And even though Frank Whittle invented the first jet engine in the late 30s, the Germans were the first ones to use it as an application, use it in an applicative form in the Messerschmitt 262. That's for gas turbines. Yeah, exactly, nerd. Mm-hmm. Yeah, well, remember, he said turbos, like cars and rockets. I mean, if we want to get technical with this, yeah, steam turbines have been around for hundreds of years. And if you really want to get technical with this, a centrifugal supercharger came about sometime in between steam turbines and gas turbines. What they were doing in World War II with propeller planes is they had essentially a big freaking turbine fan or a compressor, right? So one half of that jet engine thing that I was telling you about on the front of the motor, and basically that would suck in a ton of air, it would compress it, and then it would force it into the engine. But it wasn't driven by the exhaust gases of the plane engines. If you kind of picture a Spitfire or a Messerschmitt 109 in your head, there's pipes coming out the side. So it was an open exhaust. They were running open headers basically for better performance, right? That's true for cars nowadays, but the emissions people might get a little mad at you if you do that. So they weren't using the exhaust gases. So it wasn't a turbocharger. It's called a supercharger. It's a centrifugal supercharger that is basically attached to the crankshaft of said engine, and that's used to suck in air and force air into the engine to get better performance at high altitude. Because when you're up there, when you're up at 20,000 feet trying to dogfight somebody, the air density goes down. That's less oxygen going into your plane. So you need to compensate for that by either delivering less fuel and then you get less performance, or you run fuel rich and your motor stops running because you flood the thing, right? The supercharger was the way to solve that problem. However, at the exact same time, Saver, a young engineer at Lockheed in the late 30s came up with the idea of using exhaust gases. Using the exhaust gases to create more compression on top of that supercharger, compounding them into staged forced induction is what it's called. The P-38, if anybody knows that plane, has Allison 1710 engines on it, the same engine as the P-40. But the P-38 doesn't perform like a P-40 if you know your World War II planes. The P-38 is way better. Why? Because this engineer at Lockheed came up with the idea of a stage forced induction for the engine, turbo supercharging. That's why the P-38 has those intakes on the back behind the engines. It's an intercooler. He's staging and charging the air. So the supercharger takes the air in. The turbocharger, which is driven off the exhaust gases from the motor, charges it some more. And then they exchange the heat with those intakes on the back. And then it goes into the engine. So the engine is getting nice, cool, dense air even at high altitudes. So, like, a lot of different guys were working on turbines at the time. There's no one specific thing. There's no one specific guy. Like, Frank Whittle invented the turbojet. Kelly Johnson, I don't think Kelly Johnson, that was the name of the engineer at Lockheed. The guy that engineered the P-38 engineered the SR-71 as well. That guy is a pretty good aerospace engineer, if you ask me. Kelly Johnson was working on staged, compound turbo supercharging. That's something that's cutting edge even by today's standard, but for cars, you know? It was all kind of being developed at the same time. And what that called, Saber, is called convergent design. You want to try to get something to compress air and then shoot hot gases out the back to make thrust. There's only so many good ways you can do that. Inverted flight tanks cause negative G pushover problems. I learned everything I know from Top Gun. Nice. I know about steam turbines, but the turbos like we use every day, like the level that they're at now, and they're made for cars like they were based off of the one that was made for a fighter plane. Yep. P-38, turbo supercharger, man. Kelly Johnson. Same guy that made the U-2, F-104, Lockheed Constellation, SR-71. Yeah, that guy. He designed and engineered the P-38 when he was like 27. I had trouble making my bed every day when I was 27. All right? Pretty crazy, right? Yeah, so what he was getting at, what Kelly Johnson was getting at, is what's called staged compression. Okay? Now, that's not far off. Putting a supercharger into a turbocharger and then putting it into an engine has two stages of compression. You compress it once, and then you compress it again to force more air in, and then you put it in the engine. And then you put it in the engine for combustion. That's something that was later applied to jet engines. The thing though, is that a supercharger and a turbocharger are what's called radial compressors, meaning they suck air in and they push it out sideways. Okay? You think of a turbo, if you look at a turbo from the front, it looks like a snail. You have an inlet here, and then you have an outlet that way, right? That takes the compressed air to the engine or to an intercooler in a car, right? So those are called radial compressors. Sometime in the 50s, or the late 40s, maybe late 40s, early 50s, they came up with the idea of axial flow compressors. So an axial flow compressor is basically doing exactly what that turbo supercharger thing is doing, but applied to a jet engine, but it's using an axial flow, meaning that the air is coming in this way and it gets compressed going in the same direction. The airflow is pretty linear. A radial compressor shoots air this way. It shoots air out perpendicular. Axial compressors move air along the rotating axis of the turbo, of the turbine or compressor, whatever you're trying to mess with. This is what a staged axial compressor looks like. Kelly Johnson was honing in on these ideas in the late 30s. That is a 1, 2, 3, 4, 5, 6, 7, 8 stage axial compressor. And then a 2-stage axial turbine. Pretty cool, huh? You make your bed every day now? Of course, Miff. Static fire hasn't happened yet. They depressed the tank, guys, but they might be pushing for another run, so I'm going to stay here until we see something. That is a J85, yeah. It says it right there. Hey, Finn, sorry to ask again. I'm a bit confused about the bleed line. Didn't they say during the presser that with the shuttle, the warm bleed returns to the tank, but with SLS, they do it a bit different? I didn't get how it's different, but from what I understood is that the bleed line is not let loose into the engine. Sounded to me like a closed loop system to chill it down. No mixer feed. No mixed feed. LH2 locks. Did I get this right? No. So on the shuttle, the has gas bleed does go back into the external tank. On SLS, the has gas bleed does not. The reason why? Reuse, simplified plumbing. So, got him. Stupid mosquito. It's an open loop. It's an open loop for the bleed lines. On the shuttle, though, you do have a repressurization system built in to the shuttle, the shuttle's main propulsion section, or the shuttle engine section, that back triangular shaped part with the ohms pods on it and the 3 engines. You do have a closed loop bleed line that'll go back into the tank. Why do they do that? Because the engines are going to be reused. You can afford to make them a little more complicated. With SLS, it's fire and forget. It's one-time use. Why? Why waste time on extra plumbing that you don't need? So the bleed is an open loop system. You can actually see. Give me 1 second. Let me see if we can find a picture of SLS. I gotta find a picture of the engine section from the test, or from the launch on Monday, or launch attempt on Monday. But isn't it very dangerous to have O2 and H2 mixed anywhere near the engine? They're not mixing, Finn? No, they're not mixing them. The bleed lines that we're specifically referring to with SLS is the hydrogen bleed lines. Okay, so the hydrogen bleed lines come out the sides. Here, I'll show you. Let's use Tristan's GIF here. So the oxidizer bleed lines come out the bottom of the engine here. They come out the bottom. You'll see them when they go to fire. You'll see or if you watch a shuttle launch, you'll see the oxidizer bleeds come out there. The hydrogen bleeds are up here. See that? You can't really see it too well in this picture, but right at the tip of my mouse cursor, that's where the hydrogen bleed lines are. They don't mix. They might mix in some way, shape, or form, but they bleed the hydrogen. They bleed the oxygen down here. They bleed the hydrogen up at the top of the MPS. Yeah, I know, Gah. Rent free. It goes back into the tank. Search for bleed in this. Dude, I'm pretty damn sure it's an open loop system. Let's see. There's a bleed system that takes the bleed gases from the engine and routes them back up into the tank. And when we looked at it, the pressure in that system went up higher than we predicted. The team went off and looked at it and looked at the pressure in length in line and decided that the diameter was not sufficient. You guys. Phil. They're talking about the catch can system on the TSMU in that article, man. We're talking about a completely different bleeding system. Bro, you're killing me. That's the tail surface mass carrier umbilical plate scavenging system. The engine bleed is open loop, I'm pretty damn sure. It does use autogenous pressurization, Spaceman, yes. It's the bleed system in the MPS, is that not? Okay, look. So this is what you want me. This is what you wanted me to see. This is off NSF. There's an LH2 bleed system that takes the bleed gases from the engine and routes them up back into the tank. And when we looked at it, the pressure in that system went up higher than we predicted. The team went off and looked at it and looked at the pressure and the length of the line and decided that the diameter was not sufficient, that we needed to increase it. this particular component here, the diameter of the bleed line was not sufficient. That's the catch can on the TSMU. That's this thing. That's what they're talking about in that article. I understand it says there's an LE2 bleed system that takes bleed gases from the engine and routes them back up into the tank. And when they look at it, the pressure in that system went up higher than we predicted. In the paragraph about Boeing is also prepared to replace an MPS bleed line inside of the engine compartment after renewing green run performance. That data that did. It says inside of the engine compartment, dude. There's literally vents like on the side of SLS that we saw during the launch or during the launch attempt. Like, and John Honeycutt said it was an open loop system. At least I think he did. I could be remembering wrong. I mean, it'd probably pay to get the story straight, but they could scavenge that hydrogen. But he also said that they are letting a little bit of hydrogen out of the system on purpose. And also the other thing is that if they're bleeding off the hydrogen and sending it to the purge flame, yeah, I mean, I guess that makes sense. I'd have to ask one of my buddies. I know that oxygen comes out of the bottom of those engines. And I could have sworn he said that the hydrogen was an open loop system. He could have been referring to open loop meaning the purge flame, and I may have heard that wrong. I only listened to the press conference once, and I did it while we were on stream. But usually all I need is once. Could be wrong. And so if we're going back to the original question that was asked, Finn, if they're scavenging it, right, through the TSMU catch can and the bleed line, it'll go back to the purge flame, and that's nowhere near the rocket, so they're not venting one near the other at all. But I could have sworn that's what I heard. Once again, I can misremember. I got a lot of information floating around in my head, and I have to answer this stuff off the cuff. I don't have any cheat sheet. That's why I make sure when I'm explaining something to look right at the camera, show that I'm not looking at any other cheat sheet or anything. You know what I mean? Something that I kind of take seriously, but that does sometimes mean that I miss information. I got too much stuff jumbling around up here.
Got it.
Cool.
Let's see here. Ooh, spooky inside baseball stuff that nobody knows about. But it's really not exciting. Donnie, thank you for the question here. Donnie is asking, I see cables and on the pad legs, are they at risk of damage? There's all sorts of plumbing and whatnot on the legs of the orbital launch mount.
I saw you look down.
And it would not surprise me
I did look down here. I'll show you.
If they ended up shrouded with some sort of large metal structures. It's just like when Super Heavy lifts off that mount,
you did that to yourself, Chad.
You know, a perfect amount of flame that fills the center hole of the mount and impinges no elsewhere. It's going to seriously roast that entire structure, and the plume from those 33 Raptor engines is going to be massive and destructive. So you're definitely going to want to button up that orbital launch mount and its legs as best as possible. So some kind of cladding, some kind of armoring, whatever you want to call it, would definitely make sense for not only the legs, but also like this exposed interior of the mount. I wouldn't be surprised if the whole thing, gets cladding, so we don't see like electrical boxes and valve cover. Like it just seems it's still, it's a minimally viable launch mount right now, but it will certainly change over time and get more bulked up. It's gonna have some
minimum viable launch mount. I like that, Jack. That was pretty funny. Minimum viable launch mount.
Let's see here. More questions coming in, which I always like to see. Lyle is kind of coming in at the opposite here, saying, looks like work on the orbital launch platform complete. Is that true? No, I would say, how would I describe this? I would say work on the orbital launch mount continues. That's a joke about our daily videos, which had that on their labels for like months. because this thing took a long time to make. It's David James is asking, when SpaceX attempts to catch the booster, if it goes wrong and explodes or something, what kind of damage would we be looking at around the entire area? I think, obviously on a bigger...
Hey, Snow Crash. What's up, dude?
...scale slightly than Starship, but I think a
I saw that Stationeers update,
thing
man.
to look out for here...
I'm Jones and kind of want to play
to, like,
Maybe I'm thinking I'm going to play it
of,
tomorrow. Guys, Stationeers, that actually reminds me.
When the Starship...
Stationeers redid the thermodynamics in the game. The volumetric, it has volumetric thermo now, which is, that's pretty neat.
Discovery.
Good, Snow Crash. Hey, 9-month resub.
Ship's landed.
Yeah, Tessa. I might want to take that into Sandbox and break it. And by break it, I mean make things explode. Just putting it out there.
Necessarily what I would classify as an explosion. I guess SN10 and SN11 are both kind of separate. So I'm thinking of SN8, SN9, and of course 15 landed successfully. But with 8 and 9, when they sort of landed on the flip and burn maneuver at the very end there, and kind of went kaflooey, if I can use that technical term here. You're all technical people, so I think it's fine.
Kaflooey. Hey, Shep.
So I think a booster landing failure in the chopsticks would be something along the same lines. Obviously, it would be bad, and even just the sheer weight of a booster and all that steel could surely do some damage. But the remaining fuel in the booster would not be like,
nice, Aqua.
quite so catastrophic. Now, they could certainly damage the arms. They could certainly damage the QD arm. They could damage all sorts of things around the launch site. I think most critically, the orbital tank farm would be very bad, but I don't think it would be the end of the world. Surely it would be a setback.
We're not sure, Sultan.
Surely there's things that could be damaged, but that is what I think. I mean, I am no rocketonomer, but that's, you asked, so I answered. And who is that in chat?
We got a vent. So we saw them vent down when they depressed the booster before, guys. So so we were talking about bleeds and stuff and getting gas out with rocket engines to make sure that no gas goes into your liquid fuel rocket engine, right? You don't want that. Part of that is bleeding down the lines. Because we saw this thing vent previously, means they brought the fuel lines that go into Super Heavy down from... They basically got the liquid out of them. They got the fuel out of them, and the LOX particularly, because that's what that is. It's LOX getting pushed out there, if I'm looking at this correctly. What they could be doing right here, I don't know, is repressing the lines. The lines are repressed. Help, help, I'm being repressed. No, they're repressurizing the lines, and how they do that is they start pumping fuel up the line, and they have a vent that opens to atmosphere, right? And it pumps all the gas out. And then when the liquid gets up to the vent, they'll close it. And then you know for sure that that line that you filled up with cold propellants is at the right temperature, and it's full of liquid, not gas. So let me see if I get this right now. The chill down has to happen so that they start the engine and liquid H2 and O2 does not turn into gas and hard start the engine. That's correct, Finn. Yep. But there is no gaseous mixture in H2, O2 inside the engine from the bleed cool down. Also correct. O2 yes, but H2 gets redirected with plumbing away from the engine. I think that may have been what Phil is referring to, but I could have sworn John Honeycutt say it's an open loop system, but John Honeycutt is an SLS engineer. He may have been talking about the purge flame now that I'm really thinking about it. It is an open loop system. That's not wrong. It's an open loop system no matter how you cut the cake, I guess. But it's where it's open loop. It could be the purge flame. That could be right. What is a hard start? You ever have a backfire when you're trying to start your car engine and it makes a big out the exhaust? Yeah, that hard starting is basically the equivalent of rod knock in a rocket engine. It basically, because you introduced, okay, let's, in the context of what we're talking about, say they didn't bleed the engines down, right, Finn? Say they didn't bleed the engines down. Now you have gaseous hydrogen going into your liquid hydrogen engine. What can that do? Well, gaseous hydrogen is way more flammable than liquid hydrogen is. In order to get hydrogen to explode correctly, you need to atomize it. It needs to be in gaseous form at a low pressure and in the same area as liquid oxygen. So what rocket engines do is they spray liquid hydrogen and liquid oxygen kind of at each other. They spray them at low pressure and they atomize, they combine. It's the vaporous gas that's flammable. Now don't get me wrong. Don't go smoking around a liquid hydrogen tank. That won't end well. Or a LOX tank either. Hydrogen blows up really good. Liquid oxygen makes things blow up really good. Differences, okay? So, if you have gas going in, what do we know about hydrogen gas? It will find a way to explode if you don't give it a way to explode. And you're not giving it a way to explode. So, that could open up for an overpressurization event inside of the engine because gas is compressible and liquid is not. You could overpress the line. And if you overpress the line, it can blow up. Any of the rocket's plumbing that has gaseous hydrogen flowing through it when liquid should be flowing through it can explode. You can overpressurize it. Or it could leak. It could leak and find a source of ignition, which is pretty much what happened when Booster 7 burped on the pad the other day. Anytime that happens with atomized hydrogen blowing up in a very specific quantity, right? So with a rocket engine, think of it like a fire hose. You're constantly blowing stuff up and you're constantly combusting it and shooting it out the bottom. If you have a little bit of leak, right, and that finds a source of ignition, it will detonate because you have a finite source of propellant. It'll detonate. So what's the difference between detonation and combustion? Detonation, the pressure wave is going faster than the speed of sound. Detonations are a lot more powerful, but they're really hard to sustain a detonation. It usually is just pop. So, let me give you an example of things that use detonation. Anybody familiar with the V2 or the V1? The V1 from World War II? The thing that goes. What do you think that noise is? It's detonations that are happening in really rapid succession, and that's what made the V1 fly. It's a detonation engine, or a pulse jet. That's what it's called. So, I don't think I need to say why a detonation at supersonic speeds, potentially somewhere inside of a rocket engine that's designed to combust things. A combustion is explosions, but the pressure wave happens at subsonic speed, so it explodes outward at below the speed of sound. That's the difference between detonation and combustion. If you have a detonation inside of your rocket engine, you can get an overpressurization, and the rocket basically explodes. Yeah, it'll explode. It'll pop where you don't want it to pop. Hey Doom, 71 month resub. Thank you. Rotating detonations looking down pathetic. Yeah, there has been some advancement into figuring out how to make a sustainable detonating rocket engine. Detonations are much more powerful, but they're also really hard to contain and they're hard to sustain. A rotating detonation engine, or an RDE, is a potentially new form of propulsion that could use a detonating rocket engine, and that could potentially lead to way more powerful and way more efficient rocket engines. Because remember, with a detonation, like I said, finite amount, it blows up everything. It's much more efficient than a combustion than combustion is. The V1 used deflagration. It wasn't a detonating engine. Oh, okay. Dude, I'm feeling darn tired recently. Too much to do between naps. Don't take naps then. Dude, I don't know about you, Doom. Naps make me more tired. They screw me up more. They don't help. Taking a nap for me seems like it would help. Like, oh, I'm really tired. I should go to sleep now. That sleep is never good. Never. Ever. It's never good sleep. It's not the same sleep that I get at night. So I don't like taking naps. Screw that. Let me find. Okay, so methane engine parts. I can never find this dang thing. I'm trying to find the footage, fellas. If you know, if you've watched a stream before, this is like some of the best primo footage of a rocket just voiding itself on the pad as you'll ever find. I gotta find it. It's the footage, dude. It's amazing. I can never find it, though, because it doesn't have the right tags. So if you, like, type methane engine hard start, it doesn't show up. You gotta type in some other things. Hello, one static fire. Potentially soon. Those look great, Doom. Nice. I'll find it. You just gotta give me a second. I guarantee it's worth it. It's really, really super interesting to see. This one might be it. That's not the footage, but this is a pretty. This will get the point across. I don't. This isn't the exact footage, but watch this. Headphone users potentially, watch this. You want to see what a hard start does to a rocket engine? This is why they bleed the lines, because if you don't and you have gas in the system and then you get a detonation. That's what happens. Like I said, this kills the rocket engine. You do not want a shuttle engine doing that. You do not want a shuttle engine doing that. That would be not good. Not good.
Discovery, go at throttle up.
Hey Atlantic, 8-month resub. Play it back in slow speed? Nah, I'll do you one better. Give me 1 second. I may or may not have some footage that I know of here of a shuttle engine hard starting during the shuttle engine testing program. Oh yeah, here we go. Give me 1 second. Yeah, this isn't the footage, but this is still really good footage. I'm just trying to find it here. It's around here. Let me see if the... Oh. Huh. Yeah, that's probably what would happen. Something along those lines. Yeah, that's pretty much in the ballpark. What's this one? Oh, blocked fuel injector. Oh, yeah. This is what happens if you overpressurize some of your plumbing. I believe this is what you're looking for. No, that's something different. Oh, well, that footage ended pretty quickly. Yeah, here. Finn, watch what happens. So, on RS-25s, shuttle engines, SLS engines, you have 4 turbo pumps. So you have staged turbo pumps. You have a low pressure oxidizer and a low pressure fuel turbo pump. And those things kind of go around 90 degrees, they bend back down, and they go into a high pressure fuel and high pressure oxidizer turbo pump. So low pressure oxidizer into high pressure fuel, or low pressure fuel into high pressure fuel. This is what happens if you get the plumbing blocked. You remember, Finn? You remember how mixing hydrogen and oxygen at any given point, except inside of the rocket engine, causes problems? Yeah, you're not wrong. Watch how bad or how quickly this thing goes south. So it's not coming back then. Oh, the line blew. See it up there? See it spew? Oh, look at all that hydrogen getting blown off. Very nice. Not. Yeah. Now, don't get me wrong. These aren't exact reasons. Like a bleed, not bleeding out the air wouldn't do something exactly like this. But that's the general gist of it. I don't think there's any hard start footage in here. Let's try this one. Well, that one looks... Oh, nope. What test is this labeled as? So this is engine 0103, high pressure fuel pump turbine blade failure. Oh. So this is a lesson on what happens when a rocket engine ingests foreign object debris, or FOD. Yeah. This is going to end very well. Oh, that's not good. Well, there's your problem. Found what you're looking for? Did you get it, Tessa? That's it. You found the footage. Tessa found it. All right, you guys want to see what hard starting does? This is an exact example of a hard start. This is what could happen if you don't bleed the lines out of the shuttle engine, okay? Yeah. So this is a methane engine test. And what happens is, when they start the engine up, that gas starts flowing out. You're getting a crazy amount of atomized liquid methane and liquid oxygen coming out the engine. It finds a source of ignition while the lines are priming, right, to start. Basically, the engine's trying to evac all that gas because you tried to turn it on. All that gas has got to go somewhere. And if you have an atomized fuel mixture and you leave it on for too long, basically what they did with Booster 7, you can hard start. The gases that come out of the rocket engine find a source of ignition, and that detonation goes up the business end, in through the outdoor on a rocket engine. Watch. There's your detonation, overpressurization inside, and your combustion chamber literally shears off the injector assembly. Hey, Weed. That's good. Weed, thanks for the subs, man. It is a combusted chamber. Yep. See that? That's why they're so worried about getting the bleed air right, because you could go to start SLS and that could happen. Now, don't get me wrong. I'm not trying to be like, it could go wrong. Why would you fly that? No, I'm not doing anything like that. I'm just telling you that why NASA is so worried about it. Why bleed air, getting all the bleed air, and when I say bleed air, I mean gaseous hydrogen, evacuating that out of the engine is really, really, really important. That's really important. By popular request, a performance from Daryl Nail. What's that, Thomas? I have the static fire footage up as well, guys, if they're going to fire it. Oh, there you go, Nero. Alright, what's this?
By the dawn's early light, what so proudly we hailed at the twilight's last gleaming. By the dawn.
America. That's one of the NASA commentators. That's Daryl Nail. He commentated the launch attempt 1 on Monday. Dude, it's freaking Clark Kent. He's a public affairs officer for NASA. That dude, I wouldn't be surprised if that guy just went psh, and he has the S right there. And then there's just background noise. It's like da 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 da. You know. Hey Chief, what's going on? 87-month resub. They scrubbed because of his singing, right? Sheriff's heading into the village. Would making the bleed pipe larger take completely new engineering? They already did that between the green run and the wet dress rehearsal, Fire Fistus, yeah. What's the context above this? Alright, so I wonder if NASA will proceed with their star-studded broadcast originally planned for Artemis 1 or allow Daryl Nail to continue his informative, fact-based commentary on the operations through the countdown. Daryl is now singing the national anthem. I have a feeling he's got a set of pipes. I'm for it. And by popular request. Nice. Dear God, it's beautiful. Siren, let's do this. Here we go.
On the fact that we got the overpressure notice and the deputy gave the siren, things can still happen, but the siren's about 10 minutes before
they were bleeding down that line, guys, so they're going to try again.
But sometimes the deputy is a little early, sometimes the deputy can be a little late, so that's why Jack's saying top of the hour and I'm saying 10. It's going to be around the top of the hour that we're really going to be looking for the event to occur.
Yeah, 10 minutes exactly from siren reported would be
yeah, that's probably right, Connor.
1:04 p.m. local. But I'm like in my head, I'm kind of thinking they like to generally aim for even times, and sometimes there can be a lag in communication between SpaceX and the deputies to say, you know.
So, fellas, I want to point out here. Look, see this stream right there? It doesn't necessarily look like gas. It looks like liquid. It looks like liquid that's evaporating. You ever take water? Anybody that lives where it's cold, you ever take a cup of water, go outside and do this, and it kind of does that little streaky icicle thing? You got locks coming out of the bottom of the engines. Like that.
To an orbital test flight.
Okay, we just saw a puff come down from underneath the OLM.
There's locks coming out the bottom.
Nominal.
Yep.
What does that mean? Seriously, think about it. Think about all we said about engines and how they work and what you need to do to get them ready to start. Why is locks coming out of the bottom? They're thermally conditioning the engines. Bingo. You got it. You got it. They're bleeding the engines.
Just go.
You got to do them with Raptor 2. Just because it's using methane doesn't mean you don't have to do that. You absolutely have to do that.
Yeah, but again, like I wanted to mention that puff from the engines because that's normal. That's what we would expect to see as we sort of head into the sequence here.
Hey, Avix.
And everything. I know I'm seeing our viewership surging now as we are heading toward with the siren that has been announced. So we are standing by for what we believe will be an anticipated static fire here of Booster 7 on the orbital launch mount based on the fact that Mary got the overpressure notice and that the siren was heard, but we're still going to call it a potential static fire because things can still happen here as they go down.
Off
remember,
the center engines, belt
test
fed.
campaign.
Yep.
And stuff like that. So, but based on that...
You're not kidding. There's been like an addition of 3,000 people watching all of a sudden.
Yes.
Time was the siren?
People from all around the globe, I'm sure,
2 or 3 minutes ago,
So
JW?
thank you to everybody for joining us for this test. Hopefully we get to see some Raptor fire here in just a moment.
Some chroma effects.
Indeed. Indeed we do. I know the big question is that a lot of people are going to be the timings, like how far away are we from the static fire based on the siren. We would be anticipating anything between the top of the hour here and 1:04, just about. But it could come at any time now, so we're gonna kind of pause on taking new
we'll play it in
but
a little
keep
bit.
them coming because we've still got a long way to go in our test window after this is done.
Okay,
here the test window is open until 8 p.m. local time, and we
close.
still have ship 24 on the suborbital pad. That we've got some indications that we'll be heading towards some testing on it as well. So do keep your questions coming. We will get to them. We're just going to take a brief pause on answering them so we can really focus on the upcoming firing here.
1 minute and 30 seconds to go until the top of the hour. We don't have any indication that it will be exactly at the top of the hour. That'll be about 6 minutes after the siren. And
guys, they're going to try to fire the center ring of engines. All the static fires so far have been to the outer ring of engines. The reason why they've only fired the outer ring of engines is because the starting mechanism, the starter actuation mechanism for the outer engines is ground side. The center engines on Super Heavy, the starting mechanism is rocket side. So the starter motor for the inner ring of engines is on the rocket, and the outer ring is on the pad. Now, why? Why would we do that? Well, 1, weight. 2, the center engines only need to fire up once on the way up. Or the outer engines, the outer ring of engines only need to fire once on the way up. The center engines need to come back and land, so they need to be able to be restarted. So the starting mechanism for the inner engines is actually on Super Heavy. They use compressed gas. They shoot nitrogen into a turbine, and that gets the pumps spinning to pump the fuel into the rocket engine, the bled rocket engine, and that's how they restart them.
Yeah, and it could also be.
Just in case we're 10 seconds away, let's watch.
What you're going to see here when they go is a bunch of atomized fuel come out in a nice plume out the bottom of the rocket engine. It'll come out in a nice spray like what we were looking at with that methane engine, only ideally it won't pop the engine. It'll
and
fire.
Again, based on that siren, it can be a little early, a little late sometimes, but it's roughly 10 minutes. So 1:04 is when we'd expect it, but it could be a little bit before that, a little bit after that. So just keep your eyes glued here on the orbital launch mount and Booster 7. You've got our zoomed in shot here on the left, and you've got our wider shot out on the right there to try and cover all angles of this. But moments away from a static fire here, what we think is a static fire here of booster number 7.
Yep, standing by. It's like I'm afraid to talk.
I know, right?
Intelligent Gardening is asking about water deluge. I don't think there's a water deluge at the orbital launch mount. It's not like the suborbital launch mounts where we can see a deluge start and know that there's about to be a attempted firing. So just kind of waiting and watching here with a little over 2 minutes to go.
Definitely the phrase "waiting with bated breath" comes to mind right now.
God, my guess is that there's no tri-vent on this thing because SpaceX
I wish we could patch it.
But here's a way that we can make it. One
They're
like if
using
you
a
haven't liked our
scavenging
stream
system like
equals a
NASA.
static fire, guys.
So you wouldn't have a tri-vent
I wish we
unless you
could patch in
absolutely
mission
needed
control
to.
audio and know what's going on over at Stargate.
Same. But again, if that siren's correct, we are definitely very, very close to the window when we might expect to see an engine ignition if all is going well with this test, based on the siren and the overpressure notice that Mary got.
Oh, a little bit of ice coming off the top of the booster. Or, well, at the top of the screen, the bottom of the booster.
Discovery, go at throttle up.
What's up, UI? Ice is coming off. If you look right below the clock up
A
there.
minute just about to go until
did,
104,
Noxie.
which would be 10 minutes after the siren.
A gas purge was initiated.
Alright, static fire imminent, we see the vent.
Yep. They depressed the line. They got all the commodities out of the line. They depressed it, and now they're pumping nitrogen up that line to make sure that nothing blows up. That they don't want it to. So once again, you'll see a nice white plume come out of the bottom there. A huge stream. It'll look like a waterfall. Like that. Yeah, baby! All right!
That was amazing.
There we go. That definitely looked like multiple
Nice.
engines to me. I saw a few different columns of fire coming down from underneath that booster,
Choke.
which means it definitely looks like we lit more than one.
That was definitely
I
multiple.
want to
Who
say
Ray.
3. It looked like
I
3.
want to say 3. It looked like 3 to me too. Yes.
It also felt kind of like a long firing too. Like that wasn't
It
just
was.
a,
3-second
it wasn't just a
fire.
quickie.
That seemed like a good 5-7 seconds. Just about.
Amazing.
I didn't have my exact eye on the clock, but it's Adrian saying 6 in our back channel is what it looked like there. And definitely looked like multiple ones got fired. So that would, at the very least, be the first multiple engine static fire on Booster 7 and the first multiple engine firing on the orbital launch mount as well.
Gotta love it. And,
Gotta love it.
If it was in fact 3
Love to
engines,
see
then
it.
you know what? The
Going
thrust
throttle
was
up.
3. So the prophecy has been fulfilled.
Ah, there we go. Yes, the prophecy has been fulfilled.
Wait, they gifted us up to turn Twitch.
Yeah, but it definitely
Thanks,
definitely could have been 3. Like we're just wanting, like, we're just looking at the back. We're looking at the data. We'll be back with we're just sort of reviewing what we got on here too. Alex is saying 1 from each ring, it looks like, as well, got fired, and that definitely looks like 3 that were static, and it looks like they may have been from different rings of engines. So very, very good on here, and they fired for about 6 seconds here in tandem. So good forward progress. The vehicle looks healthy on its launch pad here, although it's not launching today. It's just the launch pad. So, and we haven't seen a depress yet. That's a very good note in chat. Have not seen the
Lunch
depress.
when?
So
You hungry?
we will continue to keep
Oh,
all
lunch.
of our
I don't know.
eyes and attention on Booster 7 here, but all indications are that we definitely had a static fire of
Yeah.
at least, it looks like 3 engines.
I was waiting for Chris to stop, but Alex, yeah, I didn't see a chill down, or not a chill down. I didn't see a cool down, guys. So the engines right now, that lock stream is still there. You could barely see it, but the lock stream is still there, meaning that they didn't depress the engines. They didn't purge out the engines. They also didn't hit the booster vents. They didn't bring the engines down from flight pressure, meaning the whole system is still primed. We might see another static fire here.
As well for some static fire events there or some...
Another textbook indicator, sorry, I don't mean to keep muting them, but another textbook indicator is the fuel lines here. We did see them vent down that fuel line. So right now what they're probably doing is refilling this line. You could see that there are some gases coming out of the fill line right there. These are basically the fuel lines that go up into this lobe-shaped thing, this service mast, that fills the booster up with fuel. Now, here's the thing. Maybe they topped it off with fuel, and maybe they purged out the fill line. If they purged out the fill line and the booster still has an adequate amount of fuel in it to do another static fire, you wouldn't see this thing repressurize. It would just vent like that until it gets to ambient temperature. How long can it stay primed? As long as they can maintain tank ullage pressure, Chief, it should be fine. And if they're plugged into the scavenging system, which they are, that the bleed gases they can use to repress the tanks, like on the shuttle. Shuttle did that. If they wanted to refuel the booster, they'd need to depressurize the booster. No, not at all. You wouldn't need to depress. Not potentially. You might need to vent it down a little bit. I would bring it down from flight pressure from what I've seen, yeah. There's no depressurization, guys, meaning that the booster is still full. There's still fuel inside of it. Rockets often pressurize and they stick to a flight pressure, and they try to keep that flight pressure inside of the tank static throughout the entire ascent. They do that in the form of a pneumatic system. As the liquid fuel drains out of the engine, they pump gas in there, and the gas keeps the tank pressurized. Rockets do that for structural purposes, because these tanks are oh, there's a depress right there. These tanks are not. They're not very strong unless they're at full pressurization. Let's see how long this depressurization lasts for. We got depress on the methane and the oxygen tank. If it's quick and they stop right there, up. Check that out. Purging the line again. They're getting all the bleed gases out of this line, guys. I don't think we're done here. I think they're topping it off with fuel again. We gifted a sub to what was that? EJ, oh gosh.
Letting Alex and Adrian work
Good
on
call,
that
Alex.
in the back channel
Another
there.
one. Another one.
1:09 p.m.
So, once again, they're using really freaking cold propellants. These liquid methane and liquid oxygen, or methane and oxygen, they're usually gases, right? In order for them to exist as liquid, they have to be at pretty high pressure at very low temperature. That's how they get them to be a liquid. When you have a launch pad that's baking out there in the Texas sun all day and you try to put a cold propellant through it, the same exact thing happens when you take a cold beverage out of the fridge on a hot summer day. It starts to condense and the temperature goes up. Here's the thing. You don't want the temperature on your liquid methane and liquid oxygen going up. If it goes up, it turns to gas. There's only a pretty shallow range here for liquid oxygen and liquid methane to exist as liquids. You get too hot, it turns to gas. You get too cold, it turns to a solid. And then you really got problems. So, what they're doing here, what this vent right there, what that vent is for, is because they evac'd that line when they went to fire it, so you don't need the fuel lines to the pad full of fuel. You don't need them primed when you fire the rocket engine. That's just could potentially introduce an explosion where you don't want it, right? So they depressed that line and they gas purged it out with nitrogen, most likely, or they just let it depressurize and evap off. But we saw a small depressurization from Super Heavy there. That was a small depressurization to bring it down from flight pressure. And Alex, you were right, to bring it down from flight pressure to the nominal pressure for tanking. You don't want the pressure to be too high inside of the booster when you're trying to put fuel into it. Alex, you're right. Now that I'm really thinking about it. So, we saw them re-purge and bleed out the fuel lines right there going to the tail service mast, which means they're going to top this thing off with fuel again. I think that's a pretty good indicator. I think we got this. Oh.
I feel like more light, if that makes
There's a
any
purge
sense.
again.
It's like we should have seen more light being generated by a raptor plume in that area.
Yeah. So again, like just commenting on what we saw on our cameras and just offering that out, but we will.
Yeah, Thomas, I see.
Definitely, wait to see what SpaceX has to say for how many fired here today, and for.
They use nitrogen to purge it out, Alex, because you don't want to keep liquid oxygen just kind of hanging around inside of a fuel line or a rocket engine for a long period of time. At pressure, it's not that big of a deal, but yeah, you don't want to leave it there. Liquid oxygen oxidizes things really, really nicely. It makes things rust. You don't want to leave it in the lines. So they usually, on Falcon 9, they purge out the lines with nitrogen, ground side, and any lines that need to be purged on the booster get hit with helium. I'm new here. What do we do here? Henrik, I am a STEM streamer. I teach people about rockets. That's what I do. And I play engineering video games. And I teach people about mechanics, aerospace, stuff like that.
Go and throttle up.
And you got gifted a sub. Right now, what we're looking at is live footage from my buddies over at NASA Spaceflight. NASA Spaceflight is a YouTube channel, and they have live streaming cameras, and I have permission from them to restream their live stream here. That's a YouTube live stream. And we're watching it here. We're watching SpaceX test their new booster out. They did test it, and they fired it. And right now, we're watching for the signs of them maybe firing it again. That has to do with, like, priming your fuel lines and making sure that you're at the right temperatures and you're at the right pressures to make the rocket engine work correctly. For a rocket engine to work right, you have to have a lot of things go right, and it's very easy to have something go wrong. So I'm looking for the signs of this pointing to another static fire. They're going to test it again. They're going to send it. This pad that you see here is down at the very, very, very bottom of the lower 48 United States, at the very bottom tip of Texas. This is a launch site it's Boca Chica, Texas is where it's called. It's near Brownsville. And this is where SpaceX is testing their successor to their Falcon 9 rocket. Falcon 9 is the rocket that has pioneered reusability, amongst other things, that the first stages come down and land. This is the next level. This is like next level Falcon 9. This is called Starship. What was that tank farm venting a second ago? I didn't see it, Snibbles, so I'd have to look.
The leftmost one with the 20-second engine static fire.
How flimsy is the tank at no pressure? That's a good question, Mullet. You ever have a soda can? You ever try to crush a soda can when it's empty? Try to do it when it's full. You're not going to, unless you like jump on the thing maybe. Right? About that. It's about that flimsy. Starship can stand up by itself. But it's kind of sitting there like this when it's standing up by itself. When it gets to flight pressure, it's proverbially standing up straight. A lot stronger. Fun fact, dude. Like here. Well, do I have the cans from the other day? I do. Here we go. See this aluminum can? This is from SLS coverage. Starship's tank walls are not much thicker than this. True story. Those things are about 4 millimeter tank wall thickness on Starship. Yeah, it's flimsy, dude. If you hit it with a bat, you could put a dent in it easy. Well, now, I want to be clear. This is aluminum. That's stainless steel. Stainless steel is a little bit stronger, so you probably take a little bit more effort to put a dent in it with a baseball bat. But when it's pressurized, you wouldn't be able to put a dent in it. But also at the same time, don't hit things that are pressurized with a baseball bat. Probably not a good idea. Just, I mean, for your safety. You know, for your safety. If you want to shoot an M80 at it, then, maybe. What are you talking about? You don't have any Husker do's, Husker don'ts? You only have sparklers and streamers? Brother, it's not what you want, it's the consumer. It's the consumer. I'm sure your doctor is thrilled with you trading Red Bull for Nas. That was a one-time thing, Admena. No, Scary, nothing, Ken. That's good life advice. Do not hit rockets with the bat. Only the toppest of top-tier safety tips coming from this stream, Finn. Yeah, no, Nikita. Yeah, I know it's not smart. That's why I said don't do it. So what you're saying is if I jumped on top of Starship, I can crush it like a soda can? If you weighed as much as your mom, then maybe. Freaking roasted! Oh, I got you good, man.
What can be done at the same time? So the more static fire tests that we see, the better for us. And the better for them too. As Jack will say, more data, more better.
Right, because at the end of the day, right, this is science in action. Right? I mean, this is having a hypothesis, testing it, looking at the data, and understanding if the hypothesis is correct or not. And if it is, you've validated your data model. If it's not, something needs to tweak. What needs to tweak? The model or the vehicle.
Are you all right?
This is how you
okay?
do it.
Yep.
I don't know if you caught the bits from Triple Nickel Pickle Tickle.
So we're seeing, for example, one of the indications normally that they're pulling down.
Did you send me a message?
Is apart from the depress fan that we saw just.
Have you played Re-Entry?
It's also
I know about Re-Entry. I haven't played it on stream.
Line is defrosted.
Good to know, though.
With very, very little ice on it. We're also seeing that the recondenser active on the orbital tank farm, which usually indicates a D-tank is in process right now.
Now, to actually answer your question, Jackal, we're probably not heavy enough to be able to like jump on this thing and break it. But see, that's one of those things where I'm just gonna say that I don't know, because in the very same way of like how you shouldn't go and hit a rocket pressurized with a baseball bat, you probably shouldn't jump on it either. That might do nothing, but at the same time, I'm not gonna say it's not gonna do nothing. It might do nothing. It might do something. Gonna cry. Maybe static fire your boosters, maybe? Maybe launch and stage?
Like, because today...
It wasn't a genuine question, but thanks. Yeah, I got
today
you,
with
man.
Multiple engines firing on the OLM was not just about getting multiple engines firing, but it was about understanding the acoustics, understanding
I don't know what you're
the
talking
dynamic,
about, Jen.
understanding the
Zero, man, I have no idea what you
going
mean.
through the OLM and the booster at that point as those engines are igniting, right? It's gathering that piece of
jumping
the
on the rocket is not a validated procedure. No, Kurlani, that's not what I'm saying. I'm not saying that jumping on the rocket is not a validated procedure. I'm saying you haven't tested whether it's a valid procedure. You don't know whether it's a valid or invalid procedure. Differences. Dent in the booster.
Translate through the structure, validating those engineering models. Because one thing that I'm not surprised to see today is the staggered start sequence.
It's not what you know, Jake.
Really
it's what you can
prove.
prove.
Like the Raptor 2s and the RS-25s, and even the Merlin 1Ds need to start in staggered formation for the acoustic considerations in the aft part of the vehicle, because basically if you light them all at the same time, you can have overpressures, you can inundate your area with acoustics that could make things leak, that could rupture things, but that slight staggered start sequence translates all those loads through the vehicle in a very safe way for engine start.
Yep, he's right.
One thing that I just saw on chat, and they might be totally right here. What if they do next long duration firing on 3 engines?
Not a pressurized
That could be next, yeah. Gathering that data in the hold down position would also be a very logical thing for them to want to gather. Yep.
Yeah.
Someone in chat saying wait until they do 7 of 9 engines. I appreciate the continued Star Trek references here today. Beautiful chat. Keep them coming.
Beautiful stream. And
but
chat.
no, honestly,
Love it.
like yeah,
See
Adrian. Sorry. Yes, Alex. That.
No, on the wide shot. What are you talking about?
My
right
gosh,
here?
I'm so sorry, Alex. That just. I'm
Start
so
of the
sorry.
Giants, dude.
It's not bad being German.
That is a vent line
That's
right
also
there.
true.
Other
And
than that, I
Adrian's a
don't
very
see
good
any
guy
vents.
too. If there's someone to be confused
Yeah.
with, it is him. But no, just very seriously, gathering that extra data on long duration hold down firings is not a bad idea either. Yeah.
Someone just pointed out, how can be detanking if we see no vents and boosters are still chilled? Well, you don't need the booster to be venting for it to be detanking. They have the QDs on the booster, and that basically helps filling and draining the booster. So you don't see the frost immediately fading away. You usually see it going a little bit down, and it just fades away completely. So yeah, right now we're waiting to see what happens, and yeah, next thing after this, not today probably, but maybe at a later day, perhaps tomorrow. Who knows?
Perhaps.
We might see another engine testing from Booster 7, and that could be right a long duration firing of 3 engines. Maybe this time an actual 3 engines.
You get more seat time since the last time we talked,
if
dude.
there wasn't indeed a board there, we might actually see all 3 engines firing for a long period of time. Which we will expect that to be about 20 seconds more or less, right? Just like we saw with a single engine. The only difference though, when they did the long duration one, was that engine was different from the one that they fired the previous day, well, 2 days before, which was a short one. So it was different engines, but still, we might be able to see, might be on the cards for next testing, and afterwards, we might be going for more engines. I will say, I'm thinking the next group will be 9 engines. 9 engines.
What's that, Alex?
Yeah, and basically with 3 per ring, like the inner 3 from the 10 of the middle ring, and then another 3 from the 20. That's my guess, at least, but that's probably a little bit of like a few days away.
Indeed. Alrighty, so looking, keep the questions coming. Please keep the questions coming. We are looking for everything, but I do definitely want to say, Zondorian, thank you so much for becoming a Padrat member. That really, really means a lot to us. Brent Freeze as well, Padrat. Looking at ADHD becoming a Red Team member. Tom becoming a Padrat member as well. Thank you. That continued support really means a lot to us. Aaron with the Capcom membership, that gets you access to our Discord. So if you like all the fun joking, especially that Jack and I do back and forth, well, now you can have it 24/7 in your life with our Discord if you come to the Capcom level. So thank you very much for that.
Just continue to think of all of these as Pokemon saying like Capcom. I can't get it out of my head.
That's awesome. I like that. Oh my god, I wasn't expecting that, Jack. That's amazing. John with a Padrat member as well. Thank you so much. And Samuel with a Capcom membership, so all the fun continues for you over in our Discord. And Joseph, thank you for becoming a Red Team member. Thank you so much.
No, Jay, I just haven't felt the need to say anything.
Jimmy, thanks so much for the support as well, noting that Siren is in fact still required before static fires. Very, very good. So Alex, here's a good question for you.
Yeah.
Do you think they have applied to the FAA for a launch license yet?
Did you ask me something about time?
Oh yeah, I do think so.
I'll talk to you about it later.
Here is that launch license stuff.
Oh no, on the stream. Oh yeah, no. Yeah. All right. Let me fast forward. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding.
For Firefly, they had.
What am I looking at? When does this happen in the static fire?
For a launch license?
What happened to then? When? When will then be now?
And they had one initially that only covered pre-launch testing, but then they had another one for launch. Now,
they've gone to plan.
Starship has already pre-launch testing covered by another license differently from this. So in theory,
it's always a good day when we get to quote Spaceballs.
Actually finish that pre-launch testing, and then
no, it doesn't.
They will have all the data needed to feed that into the paperwork for the full kind of thing that they need to do for the launch license.
Probably, Sile, yeah.
License. Now, does that mean that they
need
to complete all the testing on the ship and the booster? I don't think so. I think probably with just completing testing on the booster and ships separately, for example,
what happened to them? You missed it. When? Just now. You're at now.
It will take them to get that
I lost the sweeps and the creeps. Man, sometimes I feel bad because Adrian's providing a lot of, that's Alex. Alex is providing a lot of useful information, and I'm just sitting here going.
I do think it's probably hanging on some of those test milestones to be completed, and once we see that progress, I do think we might see the launch license dropping at any time. That's my total guess.
Yeah. And James Mays here in chat is noticing that the OLM line is refrosting, but I believe you were telling me earlier, Adrian. Dang it, I did it again. Alex, why am I doing this? I am so sorry. Oh my god, I feel so embarrassed. Yeah. I know you are Alex. I'm so sorry. I believe you were telling me a little bit earlier, Alex, that that's actually expected when they detank, correct?
Yeah, so usually what happens is that the engine still vents after, while they're detanking. We see that on the ships. The only difference that on the ships is really noticeable. Like you see the venting from the sides of the ship and everything. And but here all you have is the lines that go into the engines for recapturing the methane for engine chill. Now that means that when they're detanking the booster, you might see the same behavior here. So right now I'm seeing some of the frost actually go down a little bit. I'm doing A/B checks here, and I do see the frost coming down a little bit here. But you might see the engines getting a little bit chilly and a little bit frosty from time to time. Now, when do we know they're actually going again?
Get some sleep.
Like we did before? Well, when the frost
you don't want to go into a promo interview looking like a pile of dirt. Not saying that you do, but gotta make sure this is good to go. See all this? Premeditated, partner.
And going to ship 24, that's probably on.
That's just how I look at all times.
As well, but we'll see.
Me too.
Yeah, and we are working on the replay, so we will definitely have a replay for you. We'll have a replay here for you, but we're working on it and getting those angles together. So
just wear your paper bag over your face, easy.
Bear with us. We're hoping to be able to bring that.
Yeah, that's great advice.
So here's another good question here for you, Adrian. Do you think it's possible to test Booster 7 with a hop, no Starship on top, and possibly catch it? Thought it would be cool to see. Thanks, Matthew, for the support as well with that. Alex, talking while muted?
He called him Adrian.
Excuse me, I didn't see the question.
Do you think it's possible to test Booster 7 with just a hop, no Starship on top, and possibly catch it?
Yeah, I don't think so. I think that they're going ahead with I think they're going ahead with a launch. Because if you're gonna fly the booster, why not put a ship on top, right?
The other thing is that I'm pretty sure Super Heavy won't. You probably can't static fire that thing with 33 engines firing. It'd rip itself completely off of the pad. Yeah. Gotta remember, the pad is designed to hold Super Heavy with 33 engines firing with like 250 tons of Starship sitting on top. Firing the booster by itself is gonna make it. It'll rip itself right off the pad. And how do I know? Shuttle SRBs will do the same thing. There were instances during the shuttle program where the explosive bolts that hold the shuttle to the mobile launcher platform didn't go. And it wasn't really a problem because the SRBs are so powerful, it'll just rip the shuttle right off the pad, and that's exactly what it did. Fortunately, the shuttle isn't connected to the pad other than fuel lines, and the only structural attachment point for a shuttle stack to the pad is the SRBs. So if the bolts don't go, it just rips the bolt off. Yeah, think about how much upward force you're pushing with to be able to literally stretch and rip a bolt. Yeah, and the bolts are not they're not skinny either. They're like this, I don't know, a couple inches, about that long. Yeah, so I'm pretty sure you wouldn't want to try firing super heavy with all 33 engines with nothing on top. That would be, yeah, no, that wouldn't end well. It would break something. What would it break? Don't know. Pretty sure it would break something.
Still going. You can see the engine chill line is frosty. I'm even seeing some condensation on the left side near the band down
They
the
really
line.
let a lot of problems go with the shuttle, didn't they? Blue, you know, yeah, what I like to tell people is that the Saturn V in the Apollo program got cut down in its prime. Shuttle didn't even have the shuttle didn't even have its prime. It was doomed to fail because turns out when you try to engineer the most complicated launch vehicle ever devised by man, and you try to do it for the budget of the Gemini program, it doesn't really end very well.
I will go ahead.
True story. Go look it up.
For a recycle again.
Oh, here we go.
But that was a depressment.
Methane depress. Yeah, Dio, probably. Alright. This is a prolonged depress on the liquid oxygen and methane tanks. I think we're done here. Yep, we got full venting across the board.
I don't even know if they can hear us. If we talk now.
Exactly. Sometimes it's fun to just listen to the audio.
So what you're seeing out here is that's gaseous methane being vented right there, and then liquid oxygen is being vented down here. They're bringing the tanks down from flight pressure.
Yeah, there you go. That's a long depress vent.
Yeah, they're bringing them fully down from flight pressure. A depressurization this long usually means that the tests are done for the day. Did they do a second one? No, Jay, it looks like they were tooling up for one, and then they just decided, nah, never mind. But hey, we did get a static fire, which is good. That's good. Good stuff. Hey, but what is that? You know what's odd? With everybody complaining about the scrub on Monday, nobody pointed out that the pre-launch testing on Apollo 1 took the lives of 3 people. So yeah, take your time and get it right. Yeah, it's almost like people are being selective and entitled about it. Yeah, that I tried to illustrate that with my response to the press conference yesterday. Yeah, I know. It's funny. Okay, so guys, I am going to play some F1 Manager for a little while, and because it took about 2 hours for that coverage there for that static fire, we're gonna go F1 Manager for a